Boom. All right. So, all right, that thing, and they're saying which one of these two is the inverse function? Which one of those is the inverse function? Yeah, it's this one, huh? So they're just getting in your mind, it's just an inverting of x and y. Inverting of domain and range. Good? On the other screen. So we're going to do to find, so you got x, y, x, y. Oh, this is x, y, x, y. So what's the inverse going to do? Just swap them. Yeah, they're just, so the inverse, this is x and y, is just going to trade. These guys are just going to switch. So it'd be negative 4, 3. That's a big negative sign there. And it's going to be negative 15, 4. They're going to swap, etc. Get the idea? So which one is that? C? Yeah. Make sense? So they're just making sure you're real clear with inverse function, just invert x's and y's, domains and ranges. So on this one, they're basically giving you one function and another, and they're saying, hey, find f of g. That's what you did in last night's homework, right? Plugging one function inside the other. So you know how to do that, right? They're saying, what is f of g? In other words, put g inside of f. So let's do that. Let's take all of g and pop it inside of f. So that'll be 3 times something plus 9, and the something is the g, the 1/3 x minus 9. Is that good so far? This is g here, huh? So I put g into f. I plugged g into f's input slot. Good so far? And then multiply it out, and those cancel right away, right? 3 times the third just cancels. So we just have x minus 9. You don't need all those parentheses and everything anymore, which is just x. Now, I don't think we talked about this. I think I ran out of time. I wanted to talk about it last time, but didn't have time. What just happened? What does that mean? That means we just took x and we put it into g. Remember, functions always go right to left for plugging in, right? You know, like g of 2, that doesn't mean g into 2, it means 2 into g. It's always right to left with functions. So this means x into g and then g into f. And what came out? The way it started. We started with x, ran it through both machines, g and f, and it came back the way it started. Think about what that means real life. If I take something and I put it into one machine, does something to it, take that output and put it into the second machine, and it undoes it and makes it back the way it originally started, what does that mean about those two machines?
They're inverse functions.
They're inverses of each other. One is undoing whatever the first one does. Does that make sense? How do I know that? Well, we started with x, and we put it into the first one, put it into the second. That's what it means. F of g of x means run through both machines, right? And it came back out as just plain x. If it comes out the way it started, that means one of the functions is doing the opposite of the other, or they are the opposites of each other, huh? Because one of them undid whatever the other one did, and it came out the way it started. It'd be like I took a piece of bread, I put it in my toaster, comes out toast, and I put it in my de-toaster, don't really have one of those, and it turns it back into bread. Right? If it comes back the way it started, then the second one's an inverse of the first one, or vice versa. They're inverses of each other, right? That's what it has to mean. I don't know if I made that clear last time or not. I don't think I did. Anyway, so that's what they're testing here. They're saying, hey, is it just going to come out x? And you do the work, and you go, yep. If it doesn't, if it comes out something else, like 3x plus 7 or whatever, then they're not inverse functions of each other. They're not undoing each other. But yeah, if it just comes out plain simple x, just like it started, then they are inverse functions of each other. So the answer to part A is going to be x. Guess what the answer to part B? B is just going to run them the other way. See how they just switch the order? So guess what? We already know they're inverse functions of each other. So if you run them in the opposite order, it's still just going to come out the way it started. It doesn't matter what order you do them. If they're inverse functions of each other, they're going to undo each other, whatever order. So you can save some time in your homework here, guys and gals. Just if the first answer is x, then B is going to be x as well. And C is going to say, hey, are they inverses of each other? And you're going to say yes, because it just came out x. So the answers are x, x, and yes. A, B, and C. Whereas if the first answer comes out anything other than x, well then they're not going to be inverses, and you got to do b. Who knows what part b is going to come out to be? And the answer to c would be a no. Making sense? All right. All right, so same thing. They want me to basically plug one of the functions into the other, do all the algebra, and see if it just simplifies down, cleans up to just be x or not. So I got to take this one, all of g, and put it into both the input slots, the x slots, in the f, right? Remember, the x in a function is like the holes in a toaster. It's the insert slots, right? So, all right, here we go. We get, so f of g, whoops, I didn't mean purple. F of g of x equals what? We're going to put, I don't like that weird looking color there. So I'm going to put g into f there. So what's going to happen? I'm going to get 5, let me just do the g right now, times 3x minus 4 over 5 minus x. Like so. Is that good? So I just put all of g into the two x slots in f. So far so good? So far so bad, huh? That's ugly. What are we going to do? We got to clean that up and see if it just comes out to be x. You could just take a guess on Math Excel and say it's x. Maybe it is. But on the test, I want to see some algebra. So what do we do? So this is really important for calculus. You'll have this kind of stuff all the time. How do you clean up a big algebraic mess like that? Let me make some suggestions. That whole number 5 in the front, that's just 5 over 1, huh? Whenever a whole number is interacting with a fraction, put it over 1. And then I would just let that 5 go to the top right away. I think it'd be just good to get rid of that thing. Let him distribute. So that'd be what? 15x minus 20 over 5 minus x plus 4. And the bottom won't change. We good to there so far? So that whole number 5, it's just 5 over 1, let it distribute to the top. Now, this big old mess is called a complex fraction because it's fractions over fractions. I need to clean that up. How do I clean that thing up? What am I going to do? Remember what we always do in this situation? Yeah, multiply by the denominator. What's the denominator? 5 minus x in both cases. Those are the denominators, huh? So, multiply everybody by 5 minus x. Is that making sense? And these two cancel, which is why we're doing it, because we want those two to cancel so we no longer have fractions over fractions. We just want regular fractions, not complex fractions. And then everything else will multiply, meaning this 4 will multiply and this 3 will multiply. Good to there? Is that okay so far? Am I losing you? Okay, so what do we get then? We get, what, 15x minus 20 plus, and then the 4 is going to distribute to the 5, and this would be 20 minus 4x over on the bottom, 3x minus 4 plus, and then the 3 distributes, 15 minus 3x. We good to there? Everybody see what happened? That's the step right there that really gets people. How we do it? So the 5 minus x is canceled. Just brought down the 15x minus 20. And the 4 distributed. Down here, the 5 minus x is canceled. That's why we're doing it, huh? Because we want those extra denominators to cancel. We bring down the 3x minus 4, and then the 3 distributes 15 minus 3x. Okay, now these 20s drop out. The top is just what? 15x minus 4x 11x. Bottom, the 3x's cancel, and it's 11. Look at that. It is just x. Could have just guessed. It's just x. So, we're not going to do, the answer to A is x, so what's the answer to B? Yeah, we're not going to redo it all on B, it's x. And what's the answer to C? So yes, they are inverses, right? Because it came out the way it started. When you go through both functions, you come back the way you started, those are inverse functions. X, yes, again. You okay with all that algebra, though? It's really important to, I'll put that on the test. I'll ask to see your algebra there. And be in calculus next semester, a lot of it. Good? Questions I can help you with on that? That's especially one I want to help with, is all that messy algebra. Inverses, now we're doing inverses by looking at a graph. Okay, so basically they're going to give me that picture and they're going to say, hey, which one down below is the inverse? Well, I won't give you multiple choice on the test next Tuesday, so let's make sure we can do this even if these weren't here. So how do you do an inverse graph? What do you do? What does inverse mean? Switch x, and it's an x. I'm really getting scribbly here. Switch x and y, huh? Inverse means trade, invert x and y. So, for example, go to the graph. 5, 3. Well, 3, 5 will become 5. Here, let me just do it right here. So 3. So the original graph F had 3, 5. I'm just looking at the points. 1, 2. Negative 1, 1. And negative 5, negative 5. All those will turn into inverse function points. 3, 5 will become 5, 3. X and Y will trade, right? 1, 2 will become 2, 1. Negative 1, 1 will become 1, negative 1. And negative 5 won't change because they're both the same, X and Y. So when they trade, nothing's different. So, all right, so let's put those inverse over 5 up 3. Where is that? 1, 2, 3, 4, 5 up 1, 2. Right there, huh? Over 5 up 3. Next one, over 2 up 1, over 2 up 1, right there. Connect those. Over 1 down 1, right there. Connect that. Over 1 down 1. And back 5 down 5, that's the same dot. Like that. So I just put the dots and played connect the dots. So which graph is right? A is clearly the answer. Everybody see how I got the inverse graph? I just inverted X and Y all the way down the line. Now, do you see why they put that diagonal line through the middle here? Why did they put this on the graph, do you think? Now, that's the line y equals x. Why do you think they have that on our graph? What is the pictorial significance? What's happening on the picture? That's the reflection line, isn't it? Y equals x is the reflection line for a function and his inverse. I don't know if you've ever heard that before. That'll always be the case, not just for this particular example. Always. Any graph and his inverse reflect across the y equals x diagonal line. It's always a mirror reflection across that diagonal line, y equals x. Why? Because when you do an inverse function, what do? You switch or trade or invert x and y. So that means they go exactly across the line y equals x. Because on that dotted line y equals x, all the y values equal the x values. They're the same. So if you're switching them, you're going to the other side of that line. Right? 5, 3 goes to 3, 5 right here. Right? Which goes right across that line. And 2, 1 goes to 1, 2. Right? Jumping right across the line where x and y are equal. That's why. So it'll always reflect across the diagonal line. Y equals x. Inverse graphs always do that. All right, you can use that. We've got 10. Ooh, we can't afford any more than 10 minutes.
So a linear function, the inverse would be the exact same function?
No, not linear. That y equals 9x was. Is that the one you're looking at a minute ago that I just had on the screen?
It was same exact.
Right, but that was more than a linear. That was a linear through the origin. So a linear through the origin, yes, but not just any linear would be the answer to that. Yeah, we'll see that. Let's start with this one. All right, so let's take y equals x cubed minus 2. That's our function. That's our f. You can call it f or y. That's all the same. And we have it in algebraic form now. And given algebraic form, we want to find the inverse function. So what have we learned so far about inverse functions? How do you find them? What do you do? Switch x and y, yeah. So that's going to be step one. Invert, or switch, x and y, because that's what an inverse function means. Inputs become outputs, x's become y's. So that'll become x equals y cubed minus 2. So far, so good on that. And then step 2, solve for y. Why do we solve for y? Because we got to get y alone. Y is the function, right? Remember, y values are function values. We want to find the inverse function. So now that they've switched, that y will be the new inverse function. Just solve for it. So add 2 to both sides. X plus 2 is y cubed. What do I do to finish solving for y there? What do I do to get y, turn it into regular y? The cube root. But it cancels, and so that's just regular y equals the cube root of x plus 2. Hey, do I do plus or minus? When do I do plus or minus? Yeah, plus or minus only even roots, like 2 root or 4 root, right? 2 root or 4 root, not an odd root, right? Because odd roots you can have negatives and they just stay negative. Cube root of negative 8 is just negative 2. It stays negative, huh? You don't have any plus or minus thing happening. So that's it. That's the inverse function. What did I do then? So how do you find inverse functions? You invert x and y, solve for y. Because once you invert, that's now the inverse, and then you just got to get y alone to see it. Because the y is the function value, and it's the new function, it's the inverse. So invert x and y, solve for y. That's all that's required. So that's the inverse function. Now they have a couple of other questions for us. Like, what's the domain and range of f, and what's the domain and range of f inverse? Graph them on the same axis. They actually have a lot of questions, don't they? All right, so let's do all that. Okay, so we have the original function f, or I'll keep it in black here. So the original function was x cubed minus 2, and the inverse was cube root of x plus 2. By the way, see how the inverse looks like the inverse? I mean, we don't have a picture yet. We will. But I just mean, the original function is third power take away 2. And the inverse is exactly the opposite. Opposite of third power is third root. And so subtract 2 is add 2. It's exactly the opposite function. All right, you might have been able to guess at that, huh? It's the inverse function. So anyway, now what they want me to do is domain and range and all that stuff. You guys know how to do all that. So,
Dang it.
are they just joking around? Hold on. I want to make sure I get all this on the recording here.